If something is unpredictable and contains no recognizable patterns, we call it random. So let's begin our hunt for the most random thing with a coin toss. Coin flips and rolling dice are not intrinsically random. They are only random because of our ignorance. If we could know every initial condition, the exact forces and properties at play for a particular flip or roll, we could theoretically calculate the result before it even happened. And sure enough, researchers have built coin flipping robots that can precisely control a flip to get the result they want 100% of the time. So here is our question. Is there anything you couldn't predict even if you knew everything? A process determined by nothing? And how can you be sure there aren't any patterns in what you're looking at? Maybe you just haven't looked for the right pattern yet. Or maybe you have already seen true randomness, but didn't know it because you didn't look for long enough. As if protected by a sort of camouflage, a random process can and will occasionally produce patterns. YouTube URLs are pretty much random. Sometimes, like the proverbial monkeys typing away on typewriters, YouTube generates a URL that contains, by chance, a word. The official music video for 50 Cent's In Da Club contains a synonym for bottom. This video was assigned hello, there are some sexies and a sauce. If you want to find out if a particular word has been randomly assigned to a video yet, you can search for it by using this string in Google. The point is, randomness is difficult to identify. We, especially young people, are calling clearly predictable things random. Like randomly running into your best friend at a popular restaurant. Those guys that showed up at the party last night you didn't know, they weren't randos in a mathematical sense. They knew about the party, were in the mood to go to a party, and were in the area. Pretty predictable, actually. Why have we started calling so many predictable things random? Well, many theories revolve around the amount of information and new people we are confronted with at an increasing rate, now more than ever before. Perhaps it's just easier, almost a bit of a relief, to call things random so that we can move on to synthesize other information. Coins. Well, some fantastic research has been done on what happens when they spin and flip. For instance, it has been found that the US nickel is just the right diameter and thickness to wind up landing not heads up or tails up when flipped, but on its side about once every 6,000 times it's flipped. But like I said earlier, theoretically, if we knew everything about the initial conditions of a coin flip or a die roll, we could calculate beforehand their outcome. Why don't we do that more often? Well, it's extremely difficult. Insane amounts of precision would be required because the smallest difference between two initial conditions can be magnified over time, leading to chaotic, extremely difficult to predict results. Quantum mechanics may have our answer. It describes the properties of quantumly sized things as probabilities, just chances. Not because we don't know enough yet to be certain or predict, but because, well, the idea is there's nothing there to predict. There is no beforehand we could know. Whether or not a particular individual radioactive atom will decay or not, or whatever the spin of an electron is only knowable once we look. They're determined by a deep-seated randomness woven into the universe itself. Einstein couldn't believe this. He refused to accept, as he said, that God played dice with the universe. But experiments with entangled particles have shown violations of Bell inequalities. Entangled particles are particles that exhibit similar properties even when separated by large distances. Now, if they agree on those shared properties to have, or are somehow determined beforehand to have them, their behaviors should satisfy Bell's famous inequalities. But experiments have found that instead, the likelihood of what a machine will see when measuring one particle determines how the other machine will measure the other particle. It is here when we look that the chance is determined. Explanations for this are even weirder, but what the results suggest is that the chance of seeing particular quantum qualities don't pre-exist. They happen when you look. So if you are ever feeling boring or predictable, just remember that you are made out of octillions of quantum probabilities, dice that don't tumble in any analyzable way we could ever predict. They are the most random thing. God may play dice with the universe, but they are the best dice in the universe. And as always, thanks for watching.